Today we are going to look at simplifying trigonometric expressions. Let us start. Before we can look at the expressions, we need to understand the cast diagram. We normally say this is a cast diagram. What actually happens on this diagram? It will assist us to find the exact value of a specific expression and how to also prove our identities. Now, what is important is to know that we are dealing with angles. We have 360, we have 90, we have 180, we have 270. And then starting from the positive x-axis, go in this direction, which is anti-clockwise. This is the positive side of the angle. And then starting from here, go in this direction clockwise, just know that we are dealing with negative angles. So normally we start from the positive x-axis going anti-clockwise when dealing with positive angles. Remember, in trigonometry we have sine, cos and tan. I'm going to talk about the first three common trig ratios. So in this diagram, we need to understand the quadrants which these trig ratios are positive, which they are negative. We say this is quadrant number 1, this is quadrant number 2, 3 and 4. What is important? All trig ratios in quadrant number 1 are positive. In quadrant number 2, sine trig ratio, it's the only trig ratio which is positive, and then the other trig ratios, which is cos and tan, they're negative in this quadrant. Quadrant number 3, we have tan. Tan is positive in quadrant number 3. Cos, it's negative, and also sine, it's negative in this quadrant. We have cos, which is positive in this quadrant. Sine, it's negative. Tan, it's also negative in this quadrant. To memorize this, you need to memorize the word cast. That's why we say it's a cast diagram, which is C-A-S-T. Cos is positive, all trig ratios are positive, sine is positive, tan is positive. Now that we know our quadrants, we know the signs of our trig ratios. Now let us deal with angles. In quadrant number 1, you should know that this quadrant is 90 minus x. Remember, it's 90, go in this direction is positive, go in this direction is negative. Negative what? Our angle. Sometimes it will be 90 theta. So just know that in this quadrant we have 90 plus, or we have go in this direction. From 360 go in this direction is positive, so it's 360 plus x. Quadrant number 2. 90, is it 90 plus or 90 minus? It will be 90 plus. And then we have 180 minus x. This quadrant is 180 plus x and 270 minus x. The last quadrant, this is 270 plus x and 360 minus x. I hope you can see this. Now, combining this basic knowledge with our cast, we know that it will assist us to determine the expressions. For example, suppose you are looking for cos 90 plus x. Actually, for now, let us look at 180. 180 plus x. Now we check 180 plus x, it's which quadrant? It's quadrant number 3. Is cos positive or negative in quadrant number 3? It's negative, because remember, only tan is positive in this quadrant. So we put the negative. So this is the value of cos 180 plus x. This simply tells us which quadrant. Another example. Sine 360 minus x. What is sine 360 minus x? Sine 360 minus x, it's which quadrant? It's quadrant number 4. And then is sine positive or negative? It's negative. Sine x. This is the value. Now listen, whenever we use 270 or 90 degrees, let's say one of the angles here is 270 or 90 degrees, and then we are looking at sine and cos. The function will change. Suppose we have sine 90 plus x. Which quadrant is sine 90 plus x? We know that it's quadrant number 2. Now, is sine positive or negative? Is positive. But then, because we're using 90, sine will change to cos x. Same goes to cos 90 minus x. We know that 90 minus x is quadrant number 1. We can quickly check. You can see that it's quadrant number 1. All trig ratios are positive, so it will be positive. Now, because it's 90, cos will change to sine. This we call them core functions. We can prove this using identities. Let us look at the previous. Minus x. We said this is positive sine x. We can prove this using an identity. Using an identity. Now we know that for cos a minus b, this is the same as cos a cos b plus sine a sine b. Using this, we can prove that this is equals to this. Now we are going to have cos 90 cos x plus sine 90 sine x. Now what is cos 90? We know that cos 90 is equals to 0. Then we have cos x plus sine 90 is equals to 1. We have sine x. So this will result into 0. We have 0 plus 1 multiplied by sine x is sine x. Then this is simply sine x. I hope you can see this. So going back to this, we can use the cast diagram, or we can verify using the identity. There is a lesson video whereby we look at all the identities, but in this lesson video we are looking at how to solve expressions of trigonometric functions. What is the exact value of this expression? We need to use the cast diagram to simplify this, or we can use identities, it's fine. So cos 90 plus its quadrant number 2. Is cos positive or negative? It's negative. Now since we are using 90, we have 90 as our angle. This will change to sine, so we have sine x all over. Cos 360 minus x is quadrant number 4. So we know that cos is positive, so it will be cos x, doesn't change. We look at tan. Tan 180 minus is quadrant number 2. Tan is negative, and then remember tan doesn't change. The reason why this cos didn't change, it's because we have 360. Whenever we have 360 and 180, cos doesn't change and also sine doesn't change. You don't have to change any trig ratio. Now from here we need to simplify. Negative sine x, let me do this. We have negative sine x all over this negative, okay, cos x multiplied by negative tan x, it's negative cos x tan x. From here this negative will get rid of this, and then we have sine x over cos x tan x. Then from here we need to separate. Remember this, it's an identity. If we separate this from this, we are going to have sine x over cos x multiplied by 1 over tan x. Just make sure that this tan remains on the denominator level. Don't bring it here, no. Let us quickly look at few examples. Suppose we have 2 over x, y. You want to separate this from this, it will be 2 over x multiplied by 1 over y. Or you want to separate this from this, it will be 1 over x multiplied by 2 over y. When you are separating this, actually you are not separating, you are just writing it in another form, because 1 multiplied by 2 it's 2, x multiplied by y it's xy. It must bring you back here. So from here we know that sine over cos it's tan x multiplied by 1 over tan x. Let us quickly look at how to multiply a fraction and a whole number. Suppose you have 3 multiplied by 1 over 2. Just know that this denominator will always be part of the answer, and then you simply multiply this whole number and the numerator. 3 multiplied by 1 it's 3. This is our answer. X multiplied by 2 over y. This will always be part of the answer. X multiplied by 2, we have 2x. Now same goes to this. We have this serving as our whole number and a fraction. So we know that tan x will always be part of the answer. This multiplied by this, it's tan x. Now anything divided by itself, it's 1. So our answer in this case is equals to 1. Now there is a way to actually prove that 1 is the correct answer. From the given expression, you can let x to be any number, but make sure it's not 0. You simply substitute where you see x. If you have access to a calculator, this will be equals to 1. provided your final answer will result into an answer, actually a whole number or just a number. Let us look at the second example. Now we can see that we have something which is not common. These angles 330 and 150, but we will explain it once we get to it. Now the first one, this one, we need to change. Quadrant 180 plus x is quadrant number 3. We know that sine is actually negative in that quadrant, so we have negative sine x. And remember, sine doesn't change because this is not 270 or 90 degrees. Now for cos, for this angle, we need to change this angle such that it's one of the special angles. We need to express 330 in such a way that we have one of these angles. One of the angles must be one of these angles we have on the Cartesian plane. Let us do it. So 330 is the same as 360 minus 30. 360 minus 30 is equals to 330. Now tan 150, we need to also express it in terms of the special angles and one of the angles on the Cartesian plane. So 180 minus 30 is the same as 150 all over sine x. So in this case, we still have negative sine x. Cos 360 minus is quadrant number 4, and then we know that cos is positive in that quadrant, so it's cos 80. 180 minus its quadrant number 2, we know that tan is negative in that quadrant, so it's negative tan 30 all over sine x. Now if you can check, remember between the brackets it's multiplication. So negative sine x multiplied by positive cos x. Let me take it step by step. Negative sine x multiplied by positive cos x, it's negative sine x cos 30. Okay? 30 all over sine x. Then we continue. Negative sine x cos 30 multiplied by negative tan 30. It's negative multiplied by negative is positive. So this will give us sine x cos 30 tan 30 all over sine x. From here, since we don't have plus minus in between, this can get rid of this, and then we are left with cos 80 degrees multiplied by tan 30 degrees. Now we know that cos 30 is root 3 over 2 multiplied by, we know that tan 30 is the same as sin 30 over cos 80. You can punch this on the calculator, but we can take it step by step. Square root of 3 over 2 multiplied by sin 30 is the same as 1 over 2 all over cos 30 is root 3 over 2. Root 3 over 2 multiplied by 1 over 2. This, when we want to multiply instead of dividing, it will be multiply to square root of 3. We have square root of 3 multiplied by 1 and 2 multiplied by 2. We have square root of 3 over 4 multiplied by 2 square root of 3. Now this multiplied by this, we have 2 square root of 3 over this multiplied by this, it's 4 square root of 3. So what happens is that this will get rid of this, and then we have 2 over 4, which is equals to 1 over 2. This is how we use cast diagram to solve trigonometric expressions. That's it for this lesson video. This is Bahula SJ. Thank you very much.